This video is going to talk a little bit about one method of factoring, how to sort of undistribute, and that method is called monomial factoring. The best way to start off factoring is always to look for a greatest common factor that's in all the parts. Again, a greatest common factor is the largest monomial, the largest sort of single term that would divide evenly into each term of an expression. So if you were looking over here at the right, 12x plus 42y, let's start with that one. Well, the first thing I want to consider is the numbers. When I'm looking at 12, I know that all the factors of 12 are 1, 2, 3, 4. 5 does not go into 12, but 6 does, and so does 12 itself, right? Well, when I'm looking at the 42 over here, 12 does not divide evenly into 42, but 6 does. So the greatest of the common factors between 12 and 42 would be the number 6. Well, in that case, what I'm going to do is I'm going to write that 6, and then I'm going to leave a set of parentheses. Looking for the greatest common factor, or GCF, is not a bad idea, but now what I want to know is if I factored out that 6, if I sort of undistributed the 6, what would be left behind? So that I get a full expression that's totally equal to, right, my original expression. Well, 6 divides into 12 2 times, and 6 divides into 42 7 times. Now, because I'm not taking out that x, I'm going to leave that x inside as well, and that y also. And notice they had a plus sign in between. So now I can take a look at it and say, well, wait a minute, if I distributed that 6, would I get back the original expression? Well, 6 times 2x would be 12x, and 6 times 7y would be 42y. So my factored expression, right, the two things multiplied together that would give me back the original expression would definitely be 6 times the quantity 2x plus 7y. Let's do that same idea with the next two expressions. Now, if you want to make a list of factors, you can definitely do that. But the first thing I would look at in this next one to the right is that the number in front, the coefficient, is a 4. Since 4 also goes into 24, I know the greatest number I'm going to have is to pull that entire 4 out of there. But at the same time, I've got 4 different x's, right? X to the 4th multiplied together over here. And I also have an x to the 3rd in this term. So since there's an x to the 4th, essentially that's the same thing as x to the 3rd times another x. So I know I've got an x to the 3rd, right, that's in both expressions. What I'm going to do is go ahead and put that x to the 3rd in front. And now we need to figure out what would I need to multiply, right, times 4x to the 3rd to give me 4x to the 4th. Well, I divided out the 4, and I divided out 3 x's, but I need that 4th x. And isn't 4x to the 3rd times 1x the same thing as 4x to the 4th? At the same time, again, I'm going to take another look at this one and say, okay, if I divide the 4 out of the 24, right, that's going to leave behind a 6. But I also took out that x to the 3rd, right? I've already got that whole side handled. So I shouldn't need, right, anything more than that. And if we take a good look at it, 4x to the 3rd, again, times x is 4x to the 4th. And 4x to the 3rd times 6 would be 24x to the 3rd. I've already got all the variables handled, and the numbers work out. So again, our monomial, our greatest common factor, was 4x to the 3rd. But don't forget to write down, again, removing that 4x to the 3rd from both terms, dividing it out of both terms, I had an x plus 6 left behind. Let's do that one more time. Again, thinking about 14 and 35. Well, 14 doesn't go into 35, but I believe 7 does. And again, if I made a list of factors of 14, right, 1 times 14 and 2 times 7, those are really the only things that are going to multiply evenly to 14. Again, since 14 doesn't go into 35, I want the next biggest number, and 7 does work out. 7 divides evenly into 14 2 times, and evenly into 35 5 times. At the same time, I notice I've got b's in both terms, so I'm going to take out a b. Again, 14 divided by 7, or 2 times 7, I've got the 14 handled. I need the m, but there wasn't an m in the second term, so I need to leave that inside the parentheses. 7b times 2m would be 14mb, though. I know I've got that handled. Again, 7 times 5 is 35. I took out one of the b's. Right? So I've got that b squared. I need another b. b times b would be b squared. And I believe that should be a good expression there. 7 times 2 is 14, mb. And in the second term, 7 times 5 is 35, and b times b would handle that b squared. So again, the goal is find what's common between both terms, then figure out if you divided those terms out. If you divided a 7b out of both terms, or that 6 in the first example, or the 4x to the third in the last, or the upper right example, what would be left behind? What's that quantity left behind? Again, you can always check your answer by redistributing. If you've got any questions about monomial factors, make sure you talk to your teacher. Otherwise, have a great day.